Today's lesson is going to be on solving two-step inequalities. So last class we talked about one-step inequalities, kind of some differences between inequalities and equations. As we'll talk about as we're going through this sheet, inequalities are very similar to equations. We're going to solve them the same exact way. Just the main difference is with equations we're solving for one solution. However, with inequalities have lots of solutions. That's why we're going to be drawing this number line. So example 1, let me zoom in here. How this is going to work is I'm going to run through the first 3 examples, and then I'm going to pause the video. You guys are going to try the back of the sheet, and then once most people are done, the rest of the video will be played so you can check your answers. So example 1. This should look fairly similar to a two-step equation. The only difference is this little inequality sign. But we're going to solve it just like an equation. So if you remember, back to last unit, when we have two-step equations, all we're going to do first is get rid of this constant. Remember, the sign in front goes with it. So this is saying plus 8. The opposite of plus 8 is minus 8. So let's subtract 8 from both sides. When we do that, those cancel, and we're left with 2x is greater than 12 minus 8 is 4. I solved that just like an equation, except instead of an equal sign, I have my inequality sign. Now we're left with a little one step. 2x is greater than 4. This is 2 times x, so the opposite of that is division. Divide both sides by 2. So we're left with x is greater than 4 divided by 2 is 2. X is greater than 2. So we should know we're either going to have an open circle or a closed circle. The closed circle is when we have the line underneath to indicate or equal to. Here we just have x is greater than 2. There's no line underneath. So we're going to have an open circle, and the circle is always going to be on the number that we solve. So we're going to have an open circle on 2, just like I drew right there. Now you should be thinking to yourself, alright, we need to figure out which way this arrow is going to go. Is it going to go to the right towards all these positive numbers, or is it going to go to the left towards all these negatives? Well, we got x is greater than 2. So if you think of a number that's greater than 2, you have 3, 10, a million. All those numbers are going to be towards the right. So our arrow is going to go towards the right. Just like I drew. Another little secret, if your variable's on the left, we always want the variable on the left, our arrowhead in the problem is going to point the same exact way as it does on the graph. Check that out. So the arrow in the problem points the same way as it does on the graph. Example number 2. We have negative 4x plus 10 is less than or equal to 24. So for solving this just like an equation, we're going to get rid of our constant first. We have plus 10, so we're going to subtract 10. Draw my little line to keep everything organized, so those cancel. We're left with negative 4x is less than or equal to 24 minus 10 is 14. So now we're left with negative 4x is less than or equal to 14. We're going to divide both sides by negative 4 because this is negative 4 times x. Opposite of times is divide. So we're left with x is less than or equal to 14 divided by negative 4. That's negative 3.5. But be careful. What I just got is not correct. Because like we talked about last time, when you multiply or divide by a negative number, you have to flip the sign. I divided by negative 4 here as my last step. Negative 4 obviously is a negative number, so when we multiply or divide by a negative, we have to flip the sign. So So our answer is going to be x is greater than or equal to negative 3.5. Now to graph this, obviously negative 3.5 isn't exactly on this number line, but we can just put our point halfway in between negative 3 and negative 4. So we have to figure out if we're going to have an open circle or a closed circle. Like I talked about in the previous problem, we have our line underneath, x is greater than or equal to, so we're going to have a closed circle at negative 3.5. Now we have to figure out, is our arrow going to go towards the right, towards these more positive or bigger numbers, or is it going to go to the left, towards these negative or smaller numbers? A number that's greater than or equal to negative 3.5, we could have negative 3.5. We could have 1, we could have 5, all those numbers are greater than negative 3.5. So our arrow is going to go to the right. Also the arrowhead in the problem is pointing to the right, so the arrowhead in our graph is going to point to the right. So that is example number 2. Finally, our last example that we're going to do together is this one with a fraction. Don't let the fraction scare you. So we have 1/2 y plus 7 is less than or equal to negative 10. Just like we did in the previous two problems, we're going to start by subtracting 7. So we're left with 1/2 y is less than or equal to negative 10 minus 7 is negative 17. So 1/2 y is less than or equal to negative 17. This is a fraction. Remember, when we get rid of fractions, we have to multiply by that word that begins with an R, reciprocal. The reciprocal of 1/2 is 2 over 1. So we're going to multiply both sides by 2 over 1. Those cancel. We're left with y is less than or equal to negative 17 times 2 over 1. 2 over 1 is just 2. So negative 17 times 2 is negative 34. I saw some people getting confused on the math lab, which you'll do later in class. I saw some people getting confused about this right here, negative 17 times 2. I saw some kids flipping this sign because this number is negative. However, it's only the number that you're multiplying or dividing by. So here we divided by 2, or excuse me, we multiplied by 2 over 1. 2 over 1 is positive. So that number that we multiplied by isn't negative, it's positive, so we're not going to flip this sign. So it doesn't matter about the number that's already there. If we multiply or divide by a negative, we flip it. Here we have 2 over 1, which is positive, so we're not going to flip this sign. The sign's going to stay the same. Now I understand on this number line, negative 34 isn't there. You know, I apologize. We should have made these number lines a little bigger. But we can just, write a little 4 next to the negative 3 there. We can make this negative 44, this negative 24. Just something to see that, alright, we go towards the right, the number's getting bigger. So, we have to figure out, are we going to have an open circle or closed circle? This has a line underneath, y is less than or equal to negative 34, so we're going to have a closed circle on negative 34. So now we have to figure out, is it going to go to the right or to the left? Y is less than or equal to negative 34. So a number that's less than or equal to negative 34, negative 44, for example, is less than negative 34. It's further away from 0. So our arrow is going to go to the left. Also, the arrowhead up here in the problem is pointing to the left. So arrowhead down here is also going to point to the left. So at this point, I want you to try the back of the sheet. There are 4 problems on the back. example 4, example 5, example 6, and example 7. Example 7 is, a harder example. It's a word problem. I want you to give it your best try, and then once most of you are done with the back of the sheet, the sub will unpause the video, and we will go through these examples to check your answers. So you're going to be doing the back of the video now. Take your time, show me your work, and then we'll run through the rest of these problems so you can check them. So at this point, you have completed the back of this sheet. I'm going to run through these fairly quickly so you can check your answers. Example 4. We're going to start by getting rid of our constant. Minus 2, the opposite of that's plus 2. So we're left with 6p is greater than 12. This is 6 times p, so we're going to divide both sides by 6. So we're left with p is greater than 12 divided by 6 is 2. P is greater than 2. So we're going to have an open circle on 2. P is greater than 2. So P is just going to be some number that's greater than 2. 3 is greater than 2, 4 is greater than 2, 5 is greater than 2. All these solutions are going to be, or all these numbers are going to be solutions to this inequality. Example 5. Negative 5 plus 2x is greater than or equal to 10. We want to get rid of our constant first. The opposite of minus 5 is plus 5. Those cancel. So 2x is greater than or equal to 10 plus 5 is 15. This is 2 times x, so we're going to divide both sides by 2. So we're left with x is greater than or equal to 15 divided by 2 is 7.5. So our answer should be x is greater than or equal to 7.5. So we're going to have a closed circle on 7.5. 7.5 isn't exactly on here, so I'm just going to extend my number line. This is positive 7.5. We're going to have a closed circle, so it's going to go in between 7 and 8. X is greater than or equal to 7.5. So our answer could be 7.5, could be 8, could be 9, could be 10. All of those are solutions, so our arrow is going to go to the right. Example 6. Let's get rid of that constant. So we're left with a divided by 3. It's less than or equal to 3 plus 1 is 4. This is a divided by 3. This bar means division. Opposite of division is multiplication. So we're going to multiply both sides by 3 to get rid of the bottom of that fraction. Those cancel. We're left with a is less than or equal to 4 times 3 is 12. A is less than or equal to 12. I'm just going to extend my number line again here. 6, 7, 8, 9, 10, 11, running out of room here, 12. A is less than or equal to 12. So we're going to have either an open circle or a closed circle. This is less than or equal to, that line underneath indicates a closed circle on 12. A is less than or equal to 12. A number less than or equal to 12. Could be 12, could be 11, 10, 9, 8, 7, all the way up to negative infinity. So our arrow is going to go to the left. Our last example on this sheet, we gave you a little word problem. Our math class is putting on a variety show to raise money. I didn't know what a variety show was, but I learned that it is a talent show It costs $700 to rent the banquet hall we're going to use. If we charge $15 for each ticket, how many tickets do we need to sell to raise at least $1,000? So in order to solve this problem, we need to write an inequality and then solve that inequality like we've been doing to figure out how many tickets we need to sell to raise at least $1,000. In this problem, it tells us it's $700 to rent the banquet hall. That number is kind of, it's a good piece of information, but it's kind of irrelevant to the problem. We're just looking at tickets and how many tickets we need to sell to raise this $1,000. So we know we're going to have at least $1,000. We know that $1,000 is going to be in the problem somewhere. We're charging $15 for each ticket. So we know that 15 is going to be in there somewhere. The unknown in this problem, or the variable, notice all these problems have variables. So we need some type of variable here in number 7. And the variable is that unknown piece that we're solving for. The variable here is tickets. It's saying how many tickets do we need to sell to raise this $1,000. The tickets is our variable. I'm just going to use T to represent the number of tickets. Now we have to figure out our inequality sign. We want to raise at least $1,000. At least is our big hint. I gave you that sheet with all the other names for the inequality signs. At least $1,000. So that means we want $1,000 or more. We want the amount of tickets we sell for $15 to be greater than or equal to $1,000. We're trying to raise $1,000. So we could raise equal to $1,000, or we could sell enough tickets. Rumors could be spreading about all of our great talents in the talent show, and a lot of people come out, so we could raise greater than $1,000. Now we have a nice little inequality that we can solve. This is 15 times t, so we're going to divide both sides by 15. So if a t is greater than or equal to 1,000 divided by 15, it's going to give us a decimal. It's going to be 66.66 repeating, and that's tickets. So this is an interesting answer because we're dealing with tickets. I've never heard of a place cutting a ticket into 2/3 and just giving you a piece and giving someone else 1/3. That doesn't make any sense. We need whole tickets. So we're going to have to round this number. We're either going to round it to 66, we're going to round down, or we're going to round up to 67. So we need to figure out if we need to round up or we need to round down. Let's try 66. Let's plug in 66 for t and see if our number is greater than or equal to 1,000. So when we do that, we have 15 times t. We're going to round down and say t is 66. And we need to know if that's greater than or equal to $1,000. 15 times 66 is 990. Now you should know that 990 obviously is not greater than or equal to 1,000. So if we rounded down to 66 tickets, we would not reach our goal of at least $1,000. Let's see what happens if we round up to 67. 15 times 67 is 1,005. Obviously, $1,005 is greater than or equal to $1,000. So in order to raise at least $1,000, we need t to be greater than or equal to 67 tickets. Alright, well that just about wraps up the video on two-step inequalities. we're doing the same steps every single time, getting rid of the constant and then multiplying or dividing. Remember, if we multiply or divide by a negative number, we have to flip the sign, and then to graph it, we either have an open circle or closed circle on the number we solved, and then you just have to make the arrow to the right or the left based on the inequality and what answers make it true. Thanks for watching.